Welcome to Lesson 8-3 over scientific notation. Basically, scientific notation is used as a shorthand way of writing very large or very small numbers. For example, if we look at the first number, we might be saying, what do? I don't even know what that number is. Is it billions? Is it trillions? Is it quadrillions? Well, with scientific notation, if it was written that way, there would be no doubt about the value of the number. And the same thing with the 0.000000579. We don't know, is that 579 millionths? Is it 579 10 millionths? Could we figure it out? Yes, but that would take us a while. So it's easier if we don't do that and we just write it in scientific notation. So here's how scientific notation works. If we have that top number, what we're going to do is we're going to place the decimal in the place of after the first non-zero digit, so after the 8. Okay, sometimes students ask, well, which one's the first non-zero digit? Is it the 2 or is it the 8? Okay, well, just like we read from left to right, we're always going to say this is the first non-zero digit because the 8 is not a 0, and we're going to place the decimal after that. So if I were to write this number, it would become 8.962. And then we're always going to write it with a power of 10. So the power of 10 is going to be however many places that we had to move that decimal place. So the decimal place, remember, currently is at the end of the number. Okay, and if we move it after the 8, let's count how many places we're moving it. So we're moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So therefore, when I write the number, that will be 8.962 times 10 to the 12th. Okay, when I look at the bottom number, okay, once again, I'm going to place the decimal after the first non-zero digit in the number. So for this number, the 5 is the first non-zero digit. So the decimal goes after the 5, and that's how I wrote it over here. Okay, so when I put my power of 10 times 10 to the, once again, I'm going to count how many places from where the decimal was to where I put it. So let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so it'll be a 7. But this time, because this is a very small number, I will put a -7. So very small numbers get a negative exponent, and very large numbers get a positive exponent. Okay, so that's how you take a number and convert it from standard notation into scientific notation. Okay, so the good news is to change a number from scientific notation into standard notation, it's even easier. Because all I do is like in my first example, 6.93 times 10 to the -4th. I'm simply going to move my decimal 4 places to the left. Why to the left? Because remember, negative exponents mean very small numbers. So whenever I see a negative sign, I'm moving my decimal place to the left. So let me write my number, my digits, 693 over here. And then I'm going to move my decimal 4 places to the left. So I'm going to go from here to 1, 2, 3, 4. Place my decimal and then add in zeros where I have hops but no numbers. Okay? And then for the bottom one, 7.56, I will write that number. And this time 10 to the 7th. So I'm going to move my decimal 7 places to the right, since it's a positive exponent. 1, 2, 3, 4, 5, 6, 7. And then I'll fill in my hops with zeros. So be careful. It's not you're adding 7 zeros. It's that you're moving your decimal 7 places to the left. So in this case, moving my decimal 7 places to the left simply meant I added 5 zeros. Okay, the next thing we need to do is to be able to multiply numbers that are in scientific notation. So once again, this isn't too terribly difficult. We're going to first multiply our base numbers, our 1.85 times our 1.79. And then next, we'll multiply together our powers of 10. So I will get out my calculator, and I'm going to do 1.85 times 1.79. And according to my calculator, it tells me that it's 3.3115. So I'll write that down. And then, of course, whenever I'm multiplying numbers that have the same base, I just add the exponents, right? So negative 12 plus 4 will become a negative 8. So my answer would be 3.3115 times 10 to the negative 8th. It could be that sometimes when you're doing this that you might get a number right here that is not a number that's between 1 and 10. And remember, this always has to be a number between 1 and 10. So what happens if you do a problem like this and the decimal does not come out in the right place? For example, if we did a completely different problem and we found out that the answer to it was 49.73 times 10 to the 4th. What would we do about that? Because that's not proper scientific notation. The decimal's not in the correct place. Well, all we would do is go ahead and put the decimal in the right place and make the number 4.973. And then we're going to adjust our exponent on our power of 10. So in this case, we had to move the decimal one place to the left, right? It was here. We had to move the decimal here. So we had to make this number smaller. It went from being 49 to 4.9. Okay, so since we made this smaller, we will adjust our exponent by making it one place bigger. So this will become times 10 to the 5th. Okay, and once again, why? It's because this number, when it went from 49 to 4.9, it got smaller by a power of 10, so our exponent had to get bigger by a power of 10. So if we had had to move our decimal 2 places and made it 2 places smaller, we would make the exponent 2 larger. All right, so we've done multiplying with scientific notation. The very last thing we need to do is do division with scientific notation.
I did say you are.
I couldn't understand what he was telling me.
Shall not get caught for your land, just like me. Richard, covers up.
Wow.
Sing like that during music class.
Yes.
So good. We have midtime on kids.
Landon's the only one I know. Yeah.
Well, I was
You missed.
I'm not the rapper.
I know. Even the other one was like.